Welcome friends, greetings for the day. Today we will discuss about the CPU scheduling algorithm. CPU scheduling is quite an important concept in the operating system. So today during this session we will discuss about the basic concepts related to the CPU scheduling, then what are the scheduling criteria, some scheduling algorithms, multiple processes scheduling, and operating system examples related to the CPU scheduling. So basically, CPU scheduling is a fundamental concept in operating systems that involves the allocation of CPU, that is central processing unit, CPU time to the multiple processes. The CPU is a core component of the computer systems that we already know. The CPU is basically responsible for executing the instructions and performing the computations. Since a typical computer system can have multiple processes competing for the CPU resources simultaneously, CPU scheduling is necessary to determine which process gets to use the CPU at a given moment or the given piece of time. So in simple words, we can say that CPU scheduling is the method by which threads or the processes or the data flows are given access to the system resources, for example processor time, communications bandwidth, and others. This is usually done to load balance a system effectively or achieve a target quality of service. So there are some important terms we need to discuss before starting the CPU scheduling algorithms. The first one is the throughput. So what is the throughput? Throughput is nothing, it is the number of processes that complete the execution per unit time. Okay, so we can say that the number of processes they are sending request or competing for the execution in a per unit time, or we can say per second. Second term is response time. What is the response time? It is the amount of time it takes from when a request was submitted until the first response is produced or generated. Next term is waiting time. What is waiting time? It is the amount of time a process has been waiting in the ready queue. If you want to calculate the response time is equals to the addition of waiting time and the execution time of any process. So what are the goal of CPU scheduling? So the very first goal of CPU scheduling is to maximize the CPU utilization. So we want to keep the CPU busy as much as possible to improve the overall system performance. The next goal of the CPU scheduling is to achieve the fairness. Now what is fairness? It is to ensure that all the processes get a fair share of CPU time so that we can prevent the starvation. What is the starvation? It is a condition where a process never gets the CPU time. Third goal we want to achieve by CPU scheduling is responsiveness. It means we want to minimize the response time for any interactive process to enhance the user experience. And the last goal of the CPU scheduling is to increase the throughput. It means we want to maximize the number of processes completed per unit time. So there are two types of the scheduling methods. The first one is the primitive scheduling and next one is the non-primitive scheduling. So what is primitive scheduling? So in the primitive scheduling, a higher priority process can preempt a currently running low priority process to avoid any priority inversion. It means even if a low priority process is running, if a higher priority process comes and demands the CPU, then the previous one, the low priority process, will be preempted from the CPU and the CPU is allocated to the higher priority process. In case of non-primitive scheduling, a high priority process waits a currently running process to finish first regardless to its priority. The best example of non-primitive scheduling is FCFS, that is first come first serve scheduling. Another criteria for CPU scheduling methods are, so there are three types of scheduling we can say: long-term scheduling, medium-term scheduling, and short-term scheduling. So in the long-term scheduling, we can determine which programs are admitted to the system for execution and when they will be admitted, and which one should be existed or removed from the CPU. The medium term scheduling determines when the process are to be suspended or resumed. The short term scheduling, also known as dispatching, which determines which of the ready processes can have the CPU resources and for how long they can hold the CPU resources. So the most popular CPU scheduling algorithms are FCFS, also known as first come first serve algorithm. The second one is the shortest job first, also known as SJF scheduling algorithm. The third one is the priority algorithm, and the last one is the round robin scheduling algorithm. Before understanding these four algorithms, let first understand how the CPU scheduling works. So when the multiple processes are ready to run, the CPU scheduler selects one of the process from the ready queue and allocates the CPU to that process. The selection is based on the scheduling algorithm designed to achieve the goals that we already discussed in the previous slides. Now these different algorithms have the different strategies for selecting the next process, such as prioritizing the process with the higher priority, executing the shortest job first, or using the time slices for the fair sharing of the CPU time. So the very first algorithm we can discuss here is the first come first serve, also known as the FCFS. So FCFS executes the processes in the order they arrive. It means it is the simplest one. It is the simplest scheduling algorithm. So it simply queues the processes in the order that they arrive in the ready queue. So in this FCFS, the throughput can be low. It can be a problem, since the long processes can hold the CPU for the longer time, and other processes can wait only for that time. So basically, it is based on the queuing system. So in this FCFS, there will be no prioritization can occur. Thus, the system has to meet the process deadlines. So let us understand the FCFS by the help of an example. So suppose we have the three processes named as the P1, P2 and P3. Now each process has some burst time. What is the burst time? Burst time is the CPU time, or the time taken by a process to execute. Okay, so for the P1, the burst time is the 24 seconds, or the 24 units of the time. For the P2, the burst time is the 3 units of the time, and for P3, again the burst time is the 3 units of the time. Now the order of the process arrival must is, for example, is P1, then P2, then P3. So we can create a Gantt chart for this scheduling. So here you can, on the slide you can see the Gantt chart where the P1 took the 24 seconds from 0 to 24 seconds, then from 24 to 27th second P2 executes in the CPU, and finally the P3 arrived on the 27th second and run for the another 3 seconds from 27 to 30. When we calculate the waiting time, P1 is of course 0, but the waiting time for the P2 is 24 seconds, because it has to wait to completely first the CPU is allocated to P1, so P1 will execute completely, then after that only P2 can get the CPU. So P2 will get the CPU after the 23rd second, that is 24th second. Then after completion of the P2, the P3 will get the CPU on the 27th second only. Okay. So when we calculate the average waiting time for these three processes, we have to add this all the waiting times of P1, P2 and P3 and divide it by the total number of processes, that is 3. So we can divide this average to calculate this average time. We can add all the waiting times and divide it by the 3. So we can get the average waiting time 17 seconds, which is quite higher. So after understanding that example of FCFS, now we can discuss some merits and demerits of the FCFS. So what are the advantages of FCFS? The biggest advantage of FCFS is it is easy to understand and it is easy to implement or easy to program. And it is, in most of the cases, it is fair because all the processes will get the chance to execute. Now what are the disadvantages of FCFS? The first one is that it cannot, or we can say it does not perform well in the real system. So we cannot use it in the real system. Okay. and FCFS also ignores the service time request and all other criteria that can be utilized in the other scheduling algorithms. The next algorithm we can discuss is shortest job next or shortest job first. Now in SJF executes the shortest job first or shortest job next. What is shortest job? Shortest job is the process which has the smallest burst time. So what are the merits and demerits of the SJF? The biggest example of SJF is quite optimal. It gives the minimum average waiting time for the given set of processes. What is the disadvantage of SJF? First, it needs to have a good heuristic to guess the next CPU execution time. It is not always possible. The second disadvantage of SJF is the shortest duration process will starve the longer processes or longer ones. So what are the advantages and disadvantages of priority scheduling algorithm? The advantage of priority scheduling algorithms are it is quite simple because a simple integer is associated with the processes, so it is very easy to pick any process from the set of processes. The highest priority or the highest integer can be picked for the execution first, so it is quite simple. The second advantage of priority scheduling algorithm is it is reasonable to support the priority, suitable for the applications with varying time and resources requirements. Okay, so what are the disadvantages of priority scheduling algorithm? The first disadvantage of priority scheduling algorithm is to indefinite blocking or starvation. Starvation is the quite difficult condition in the operating system where the process can wait for the longer time. Okay, now a priority scheduling algorithm can leave some low priority waiting process indefinitely for the CPU time. The next algorithm we can discuss here is the round robin. So in round robin, it executes each process for a fixed time slice, also known as the time quantum, and then moves to the next process in a circular queue. The biggest advantage of round robin algorithm is it will provide a fair allocation of the CPU for all the processes. It has the low average waiting time when the job length is vary or different. The disadvantage of round robin algorithm is that it is suitable for the task with various varied burst times, but for the task with the same time it makes trouble. In conclusion, we can say that the discussed algorithms, schedule algorithms used nowadays, these algorithms are inherited based on the requirement of the process. Thank you very much.